Hey, folks, greetings from the Offensive Security Group here at Secure IT 360, coming at you with a new episode of the Cyber Threat Perspective. You've got Mr. Spencer here, as well as myself, Brad. And so in this episode, we're talking about monitoring attack surface. And so we're going to kind of get into the weeds on this and understand what it means. You know, there's a lot of buzz around this right now. There's a lot of companies selling products or, conversations being had around attack surface monitoring. And so we're going to get into that. Do you want to kind of start us off, Spencer, and kind of tell us why it's important and what we should know about it?
Yeah. I'm going to start off with a quick definition and just give an example of what attack surface monitoring might look like. Then I thought we'd just dive into what is attack surface monitoring, what is an attack surface, what are attack vectors, and all that good stuff. So there was a really good, in preparing for this episode, I kind of came across a HackerOne article that I thought had a really good description or definition of it that I thought summarized it pretty well. And it's an attack surface consists of all the possible entry points or attack vectors that can potentially allow threat actors to breach into a system, an application, a device, or an entire network. So that is attack surface, right? So that's an attack surface. All of the possible attack vectors, all of the possible points of entry, all of the possible vulnerabilities and entry points that a bad actor might use or abuse to gain access to something. It might be data, it might be admin access on an application, it might be initial access to an environment, all those things. And it can be simple or complex. I think that's one of the beautiful things about this topic is you can start small and like very simple, and you can go to what can be very complex and very hard to manage, we'll say.
Sure. Yeah. I mean, you can take this thing to the extreme, right? And there are, like you said, it's definitely a spectrum with regards to what, how much, how often. But I think most people or most organizations are doing this to some degree, even though they may not realize it. But yeah, I mean, I see that you've kind of done some of this stuff in the past. I have too, in previous
Yep.
lives. And most of it was pointed to solve a specific problem. At
Yep.
least in my case, that was my experience with attack surface monitoring. And so yeah, I mean, there's a lot of ways to go with it. There are a lot of variations of it. I see one of the things that you mentioned was, digital versus physical. That's a consideration.
Yep.
Let's dive on that, I guess, first, and then we can talk about, break down the individual components of this, I guess.
I think that's important is when we're talking about attack surface, kind of starting from first principles, I guess, if you will. It's
Yeah,
like,
yeah,
okay, attack surface, right? What is my attack surface? Well, if I have a physical office, I have a building, right? Or maybe I have a data center, right? That's physical. That would be a physical attack surface. And when you get even more granular, right, you have the doors. You have office doors, you have closet doors that house your networking equipment. You have all these things that constitute or kind of make up your physical attack surface.
yeah.
Not to mention employees and people kind of play into that as well. And then you have digital, right? Digital is what we commonly refer to or commonly talking about when we talk about attack surface monitoring. Or if you go buy an attack surface monitoring product, you're primarily going to be looking at digital assets, right? Your website, your applications, your login pages, your certificates, your IP ranges, things like that, domain names and things like that. So digital, very much different from physical in terms of attack surface.
Yeah, and I think probably most people just automatically assume we're talking about digital attack surface, but I think it's important to delineate the two. There is monitoring, there are monitoring techniques and tools and things like that for the physical aspect, but we're going to focus, I think, more on the digital aspect for
Mhm.
this conversation, even though we play in the physical world a little bit too.
Yep.
Um, so let's get into the difference, I guess, between an attack vector versus an attack surface, because we talk about both in the context of this conversation, but understanding the two of them as different animals is probably beneficial.
Yep. Yeah, and like we said, attack surface consists of all of the entry points and all of the attack vectors, right? So an attack vector you can think of as the pathway in, or the vulnerability, or the technique that's used or could be used to compromise an organization or to gain access to something. So
Mhm.
social engineering is probably the biggest one that people think of, right? When you think of
Yeah.
attack vector, social engineering is huge. But when we look at attack surface monitoring, oftentimes you're looking at vulnerability exploitation. So
Mhm.
I have a website or I have a web application, or I use third-party libraries. All of the ways that the vulnerabilities could be exploited would be an attack vector. Misconfigurations, that's another big one as well. That's an attack vector. That's a pathway to compromising an organization or an application or network. Denial of service, of course, is another example. These are just a few examples of vectors. Again, these are pathways, these are vulnerabilities, these are techniques that would be used to gain access to something. And that's different from the surface, right? The attack surface, you think like a surface of a ship, or you think of a surface of a building. Those are the potential points where an attacker could either gain access or do harm, right? Think of the CIA triad: confidentiality, integrity, availability. The attack surface is all the points where things can go wrong. So, like I said, the web apps, the login pages, we're talking about APIs, right? Endpoints, devices, even, and identities. You know, identities are becoming more and more the endpoint now,
Yeah.
especially with cloud and SaaS services and everybody working remote. You know, endpoints are still very much in play, but identities are just there and on the internet. So
Mhm.
identities are also an attack surface. So those are some of the things we think of when we think attack vector versus attack surface.
Yeah, and you hit on a really good analogy earlier when you were talking about the physical attack surface. You know, if you think about your attack surface as as your home, right? A vector might be your door, right? I mean, and everybody understands the concept of locking the doors and things like that. Maybe even having, an alarm or motion detectors, and all of those cover different areas of the attack surface. And every window, every garage door,
Mm,
all of that would be a different potential attack vector, or even have various attack vectors. There's a difference in throwing a brick through the window and picking a lock, right? And
yep.
those are different attack vectors for similar attack surfaces. So yeah, no, I
Yep.
think that makes perfect sense. And I think one of the things, you mentioned about identities is everybody seems to be hyper focused, at least in our world, right? We kind of have a skewed perspective because we're doing
Mm,
penetration testing all the time. And we're looking for, just as an example, things like, SQL injection, cross-site scripting on web applications when we do those pen tests, but we don't always have the conversation of the identities, right?
mm.
And yeah, you're going to have 100,000 users on this app, and the app may not have any injection points. It may not have any specific flaws that create risk. But if your password policy is junk, then it doesn't really matter, right? And so there
Yep.
are aspects of this that are beyond just the technical configuration or
Yep.
security posture of a particular component of attack surface that we
Yep.
have to consider. So
Yeah. So quite simply, attack surface monitoring is just monitoring the surface and monitoring for all of those attack vectors, or the abuse or potential exploitation of all those attack vectors, right? So we are monitoring our assets to identify and assess those vulnerabilities that could be exploited by threat actors, by you name it. So this process includes a wide thing, and this topic can be is now this is kind of where it gets broad, right? So we're talking
yeah.
about what is attack surface, what is a vector versus a surface, right? And what is attack surface monitoring? So now we're getting into like the core of this episode of like, okay, attack surface monitoring. We're monitoring all those attack surfaces. Cool. This is where it gets very broad, right? Your process includes tracking changes in your IT environment, such as new devices, websites, APIs, etc. Shadow IT is another component that I kind of put under this umbrella of attack surface monitoring. So cloud apps, like I said, goes back to identities, websites, devices. So IT management, IT asset management, particularly, is especially important here. So that's the kind of introductory to attack surface monitoring, and now we're kind of go broad and kind of dig through some of those layers of what this is.
Yeah, and I think the question becomes, at least in the less broad conversation, or maybe both, but is what are we monitoring for, right? And I know you get some notes in here for us to kind of talk about that, but there's so much more than just monitoring for vulnerabilities. And I think we all kind of get
Yep.
focused in on that, right? And we want to make sure that these components of our attack surface don't create risk.
Yep.
But you could be monitoring for changes, right? You could be, one of the things that we have noticed in environments, because we actually do some attack surface monitoring for some of our clients, is, what if a new service spins up?
Hmm.
Right. Yesterday, port 22 was not open. Today it is. Now you have a surface change,
Right.
and maybe it doesn't present a real vulnerability. Maybe it's fully patched up to date, everything's fine, but it's against policy to have 22 open to the public internet
Or
network.
maybe, the regression SSH vulnerability that
Yeah.
comes out. There's port 22 is open on the internet, a new service, got stood up by IT, and now all of a sudden there's a vulnerability for that exact service and you didn't know about it.
Yeah, absolutely. And so one of the things that led us to this path, and I'll kind of take us on a side mission, but we very frequently get hit with the "I didn't know that was there" response when we find something on just about every single one of our variations of pen testing that we do. It can be web
Mhm.
API endpoints. You see stuff on internals from time to time, and they're like, "Oh, I thought we decommissioned that."
Yep.
And in some cases, some very notable cases, in fact, we would find some, we can call it shadow IT, or just, things they didn't know they had that actually turned out to be pretty significant. RDP open to the internet. Well, that's against policy. We don't do that.
Yep.
But then suddenly it's there, right? And so it doesn't have to be a vulnerability in the traditional sense where there's a CVE associated with it, or anything like that. But knowing the changes that are going on and cross-referencing those to your your inventory of systems and services, to me, is one of the largest benefits, because
Yep.
it's relatively easy to spin up a vulnerability scan that runs every week or every other day or whatever it is, but
Yep.
that's not going to find those kind of things in your environment.
Yep. Yeah, and at a previous job, that's exactly what I wrote scripts for. If our certificates expired, right, that's something that we want to know about, before they expire, right? So monitoring for their expiration date, monitoring for new domains like typo squatting. This is a perfect
Yeah.
example of like quote unquote attack surface monitoring that you'll see in many commercial products is, hey, somebody, registered a domain that's similar to yours. And maybe that's going to be a precursor to social engineering or phishing and things like that. But monitoring your IP ranges for exactly what you said is like, oh, new IT stood up a new web server or a new API got put online. So those are all things that I would write scripts for. My last job as a sysadmin, like, hey, let's just automate this real quick, send a message to Slack or Teams or whatever when
Hmm.
something new is detected. And that's a very common scenario, your use case.
Yeah, totally agree. So, I think that's probably step one, right? Is just
Yeah.
knowing what you have, man. And
Yep.
we've beat this to death on this
Yep.
show. You know what I mean? And so we're gonna do it again, guys. So hang on to your chair. We're gonna beat the asset inventory drum here for a second. So bear with
Yep.
us.
Yeah, definitely. This step number one is asset inventory. And, if you want to go to like 1.5, it's classification, right? Because, you know, presumably you're going to have things, assets that are of different value, right? Or of different uses, right? So they're going to have different value. They're going to have different risks. They're going to have different evaluations in terms of how important they are to the organization, to the business, et cetera. So asset inventory, which is, again, is your attack surface and classification. So basic, what do we have? Where is it? What is its purpose? Is kind of the introductory level, I think.
No, I agree with that. And probably the biggest takeaway from that is just having a proper process in place. And that is a huge challenge. And the larger your
Yep.
organization gets, the harder that challenge becomes. And in some market verticals, it's nearly impossible. Market verticals like, higher ed comes to mind. We do a lot of pen tests on universities and
Yep.
stuff like that, and they struggle just because they have such a large staff. They have a lot of students that do work in lab environments, and similar kind of challenges with large hospitals because they
Yep.
have so many different departments with their own IT staff. And I mean, it's tough, man. For smaller organizations with smaller IT staff, hopefully theoretically it would be easy, but unfortunately a lot of them have contractors or MSPs that manage
Mm.
their stuff, and maybe they don't even know.
Yep.
what's going up and what's coming down. So it is tough, but it is an important step.
Yeah, and it's hard when you have different or you have multiple inventory systems. Like you maybe have PDQ inventory, and then you're using something else, and then you use your EDR, and you have to kind of reconcile those.
Sure.
So I think we've said this a number of times before, and I think anybody who's done security or has been in IT will tell you asset management, asset inventory is probably the single most difficult thing to do in all of IT. And system administration, right?
Yeah.
Just tracking what devices you have, where they are, who's responsible for them, what their purpose is. That's like it's step number 0, but it's the hardest thing to do.
Yeah, and let's make it even more complicated by adding SaaS services and
Mm,
cloud-based resources on top of it, right?
yep,
Um, and to your point about classification, I want to take that a step further. It's kind of a subcategory of classification, maybe, but
yep,
understanding what assets have access to what resources. And so when we start talking about cloud-based resources, for example, we've got one client that we're working with right now where they had Active Directory authentication enabled for one of their internal software packages, and the latest release of that actually created a tunnel back to the vendor cloud, which spun up a portal with no MFA, which was, by process linked back to their on-prem Active Directory infrastructure. So what they just
yep,
effectively did was create a tunnel through the vendor back into their own environment to connect to their Active Directory, and it didn't have MFA capability. So those are the kind of things
yep,
that we want to be monitoring for and that we want to have
yep,
awareness of. And the only way that we knew that that particular attack surface component created as much risk as it did is because we had knowledge of the systems that were connected to it on the back end, right? So it's not
yep,
just, oh yeah, I know that portal lives over there. It's like, okay, what's inside that portal?
yep,
What systems are interconnected to that? And I think that kind of falls under classification. So yeah, we have a tier 1 asset,
yep,
a tier 2 asset, but downstream, what is the impact to that? Because at that point,
yep,
a tier 5 asset may become a tier 1 asset suddenly once we connect the dots on that.
yep. Yeah, and this is, many times attack surface monitoring is mostly focused at external, right? But you have internal too.
Hmm.
You have an internal attack surface as well. That gets a little bit more in depth. That varies quite a bit from environment to environment. But those are some of the things that I would think about if I'm, a sysadmin or a security person at a firm trying to stand up attack surface monitoring. I'm like, okay, I'm going to start with external. And then eventually I do want to get to an internal attack surface monitoring, but there's a lot of additional components internally that I think help. EDR is a big component of that. Your SIM and all that, your SOC is a big component of that. And I don't want to go down a tangent too far because that gets into a whole nother can of worms. But step number 1 is asset inventory and classification, right? So you have to know where your things are. You have to know what their importance is and what their value is. Step number 2 is vulnerability discovery, or I guess discovery / identification and prioritization. So
Hmm.
this is where kind of vulnerability management comes into it. So if you're following the theme here, you've got asset management, you've got vulnerability management. Pretty soon, and this kind of ties in risk management. So putting on like my ISO, like vCISO consultant hat, right? I'm thinking about all these programs that need to be implemented at an organization. And it just points to, as something that I've seen before, is like you need resources to help with that. So step number 2 is vulnerability discovery, identification, and prioritization. You have to know what vulnerabilities there are, and how serious they are, so you know how quickly or not you need to remediate those.
Yeah. Yeah, absolutely. And this goes beyond just a simple, Nessus scan or whatever tool you're using. You really need to prioritize those based on classification. You need to understand that a vulnerability is not a vulnerability. I know that's something that you
Mhm.
like to harp on quite a bit. Is those default risk ratings mean squat in most cases.
Yep.
But yeah, it does come back to having a proper process and proper procedures in place. Um, Too often we see folks spin up an ESSA scan, come back, patch the highs, patch the criticals, and move on.
Yep.
And it ignores a lot,
Yep.
unfortunately. So it needs to be a little bit more in depth than that where possible. But it's a good first step.
Yeah, and vulnerability management at this step, vulnerability management includes, your regular Nessus scans. It includes pen testing or red teaming if you're there. It includes configuration management and hardening. It includes people, process, and technology. If there is a department that is overly exposed or overly at risk for social engineering, for example, like HR or accounting, that is an input to this program, to this vulnerability management program, which is an input to your attack surface monitoring, right, initiative. So vulnerability scan, pen testing, and then also the people and process and the technology is all an input to this, and then prioritizing that all to figure out what's most important to what to fix when new systems come online or when new vulnerabilities are discovered.
Yep, couldn't agree more, man. So what do we do with all this stuff?
Yeah, so in my mind,
data.
yeah, so in my mind, we've got asset inventory, right? We've got vulnerability discovery, and then eventually we have to do something with it, like you said. And to me, that's where kind of the risk management piece comes in, is the reporting, the alerting, the remediation, and improvement. So reporting and alerting, I kind of think of two kind of separate things, but alerting is like, if IT spins up like a new service, like you said earlier in your example, and port 22 is open, right? That's something you might want to get an immediate alert about. Like, hey, SSH is open on the internet. Or, hey, our certificate for our website is going to expire soon. That's particularly important, right? If you have to maintain compliance, like PCI compliance, they're going to ding you for that. If you spin up a website and has SSL3 enabled, right? Even trivial things like that, there's going to be things in attack surface monitoring that you want alerts for. So when something happens, you want an alert when that thing is open on the internet or when there's something discovered. So alerting is a big component of that. And then reporting, I think, is important because we're kind of doing attack surface, right, to not only monitor our attack surface, but get better at mitigating the risks of the things that are out there and the new things that get put out there on the internet. So in my mind, reporting is important so we can track how well we're doing and kind of show improvement, which can also help get resources and get additional funding for the programs that you are most caring about.
Yeah, and one of the big challenges here is going to be ownership, right? And so that's something we haven't really talked about. It kind of goes back to asset inventory and having a thorough process for that. But I can in some of the larger organizations that I've worked for in the past, and even some of our large clients now, it's frequently a challenge not to find the vulnerability or identify the change in the attack surface, but to find the owner of that change so that it can be remediated safely without impacting business operations. But that's a key thing here is ownership and being able to track that back.
Yeah, as an example, I was doing a pen test last week and I found something that the client thought was more or less restricted behind their firewall, right? They thought you could only get to it after connecting to their VPN. And it was just out there, right? There was a login page that you needed credentials for, but they didn't realize that IT or whoever had, changed that firewall rule to allow that application to be now on the internet again. And that's a perfect example, right? If they had some sort of monitoring for the things that they know should not be on the internet, and all of a sudden they're getting a ping from that on the internet, they know, hey, something's up, and they get alert, they can, quickly remediate that. But that's where the reporting and constant improvement comes from is, reporting on all this and kind of gathering it together. And that's hard to do when you do it kind of like DIY, if you're building a kind of a DIY system. And that's where some of the commercial tools and things like that can be very beneficial. But yeah, the reporting, alerting, remediation, improvement step is really important. It can't be understated.
Yeah, no, I agree 100%. So we can't just stop there though, right? So we've done the asset inventory, the vulnerability discovery, we've done the reporting, and we're finished, right? So we don't have to worry about it anymore.
Yeah, you're done. You just do it once a year, and you're good. Now, this is something that's kind of a trend in information security is automation, right? And they used to call what did they used to call it? Continuous vulnerability assessment or something like that. And it was in the regulations. Like you have to be doing continuous vulnerability monitoring or management or whatever. And it kind of goes without saying, but this is something that you do all the time, or you have processes, or you have scripts, or you have tools that run all the time to be constantly looking for these attack surfaces, look for new things, look for the new attack vectors. So yeah, this is a repeat / continuous process. This is not something that you just do once and run once and then you're good. This is something you want to run all the time, have running in the background, automate as much as you can, and then do the triage manually. But yeah, definitely something to repeat and do continuously.
Yeah, for sure, for sure. So I think we can probably divide categories of attack surface monitoring products into two categories, which I think I like the way that you've broken it down here, between DIY and commercial, and maybe even a third category if we want to get into that. But
Yep.
there are tools that you can buy. There are products and services that that address this, right? And in most cases, they're pretty decent. We don't really we try to be vendor agnostic. So like, there's not one that I would recommend necessarily. I would encourage, because everybody's
Mhm.
needs are different.
Yep.
Everybody's organization kind of works a different way, and so you kind of have to evaluate them for yourself. But there are benefits to going with a commercial
Yep.
stack for this.
Yeah. So like pros and cons, I think, of commercial attack surface monitoring tools are you get more comprehensive or more advanced capabilities, right? You get reporting dashboards, and you get enhanced fingerprinting, and it's more scalable. Maybe it's faster and more more efficient, can handle more more IP ranges or websites, or it's just overall more advanced, more scalable. You get the support from the vendor, and most importantly, you don't have to build it or maintain it yourself, right? It's a product that you would buy, that's built, maintained, and features are added by that vendor. So you kind of just buy this product and you pay money for all of those luxuries, right? And that's great. And there's a number of good attack surface monitoring tools out there. The cons, though, are cost. Some of these can be pretty expensive. They can be also pretty complex. And one of the things I think is the biggest con for me is the potential false sense of security. Now, this can happen whether you do it yourself or not, right? But this is kind of like one of the things to look out for when you're doing attack surface monitoring is don't just assume that, hey, we're doing attack surface monitoring, we're good, right? Just like pen testing, just like vulnerability scanning, just like anything else, there's going to be things that are missed. So you have to assume that there's going to be things that are missed, and always be constantly wondering, or just kind of asking the question and talking to your team about, what are we missing? Are there things we're missing? Where are we not looking? What should we be thinking about? So those are some of the pros and cons of the commercial tools.
Yeah, and we've witnessed that firsthand with a couple of our clients, and so one of the conversations that we kind of have early on in the pen test discussion process is, what do your processes look like now? What tooling are you using for monitoring, security, et cetera? And we have frequently gotten the answer back, oh, well, this is the tool that we're using for monitoring and attack surface monitoring, vulnerability scanning, whatever it is. And almost uniformly, we find things in their penetration tests that either they didn't know about or is a surprise to them.
Mhm.
And even in a lot of cases, their vulnerability discovery or attack monitoring tool will have found it, but it didn't elevate to a
Yep.
high enough risk according to that tool to really be pushed to them as something they need to fix, when it turns
Mhm.
out it was actually a pretty big deal.
Yep.
So these things, when you're talking about complexity and comprehensiveness, you do have to spend time working in these tools, and you have to tune them to your risk tolerance level and your
Yep.
risk appetite, and you have to understand your attack surface, I think, well enough to know that just because the tool doesn't think it's a big deal doesn't mean it's not, right?
Yep.
I think I said that right.
Yeah, it's just like anything else, right? It's never a set it and forget it kind of thing. It's always
Sure,
something that
sure.
needs tuning and kind of care and feeding. So the pros and cons of the DIY approach, or do-it-yourself approach, is less expensive, right? In terms of hard costs, right?
Mhm.
You don't have to pay for a service or pay for a product or appliance or anything like that. You tend to understand all the pieces of the puzzle, So whether you're monitoring certificates or you're monitoring, IP ranges or websites or domains or whatever, you kind of have a better understanding of what's involved in monitoring those things. And I really like that aspect of it. And some of the cons are obviously it's going to be less advanced, right? Unless you're a professional developer and you have a lot of experience like this, what you're going to develop or build is going to be less in terms of capabilities than a commercial product. That's not to say that it's not better for your organization. Going the DIY approach might be the best option for you, your firm, your team, for many reasons. But in general, right, you might miss some features. You might not have some of the advanced capability. It might not be as scalable just because of costs and things like that. So those are some of the pros and cons of kind of the DIY approach.
Yeah, and we have in the past, I say we, me in a previous life, have had to write custom monitoring tools for custom applications and things like that. And
Yep.
I will also say that this approach is sometimes necessary, depending on what it is you're trying to monitor. So one of the things that we had to monitor were changes in our production application environment, right? So we had like offshore development going on, and we had a limited amount of visibility into where the code was and what was being pushed. So we were literally monitoring like file level changes on application code,
Mm.
not something you're going to get out of the box, right? And so depending on what you're trying to accomplish, you may be forced into a DIY approach, but to your point, you're going to have a lot more knowledge and visibility into what it is that you're trying to monitor and
Yep.
work with. So
Yeah, and the last thing I want to mention is that bug bounty. If you look at the people who do bug bounty and you look at some of the people that share their automation frameworks and tools, I think the bug bounty industry is a really great example for attack surface monitoring, because a lot of the bug bounty folks will have automation set up. So it'll automatically, pull the domains from, like HackerOne or whatever the scope is, right? It'll automatically go out and it'll look for new domains. It'll look for new sites. It will crawl those sites. It will look for important things. It will even run burp automations or zap or nuclei templates to look for specific vulnerabilities. And they will quite literally automate so much of it, and then they'll get like an alert like, hey, there might be something here to go look at, and then they go and they look at it, and sure enough they find like a big bounty or something. Or it might turn out to be nothing. But there's a number of tools that I've used in the past, like a mass is great for that initial discovery. I mentioned nuclei and burp. Those are kind of synonymous with bug bounty, with web app testing, but also can be great for automating attack surface monitoring if you go the DIY approach, right? Even just Nmap, right? Just doing an Nmap scan and diffing the Nmap from 1 week to the next or 1 day to the next. So if you're looking to do kind of a DIY attack surface monitoring program, look at what people are using for bug bounty and web app testing, because that's often can give you a lot of inspiration. There's a lot of good kind of get started type of guides for doing a lot of that automation that can tie directly into attack surface monitoring.
yeah, and I'll add to that. There are some really cool tools, add-ons or scripts or whatever you want to call it, for some of these tools that you have listed. Like with Nmap, there's an NDiff tool that will look at the differences in scans. Same thing with burp. There are extensions in the BAP store that will help you in this process, and there are even automation scripts that can be written in Python, Java, that snap into burp really well. So you can really take this pretty far with these free tools and get a reasonable amount of coverage, honestly, with some of the community tools that have been developed around them. So definitely look at the community, and don't be afraid to reach out to users of these tools, like on Discord or forums. Somebody else has solved the problem more than likely, and you can leverage that. So
yeah, and there's a bunch of open source attack surface monitoring tools that people have written that kind of tie these things together. They have plugins for the different APIs that you can connect to use for attack surface monitoring. So there's a number of tools out there. And like I said, bug bounty, because of how it kind of pairs nicely with bug bounty, there's a lot to go on with this attack surface monitoring thing, which is why we recommend things like that.
I agree. Yeah, good stuff, man. So we're going to include some resources in the show notes as well. So, check those out. And yeah, that's all we have time for this week. And we'll definitely see you guys next Wednesday. Quick admin also, if you like what we're doing here, like, share, subscribe. The biggest thing you can do for us is share this with your peers. And if you need anything, just reach out to us. Have a good one.